Hi, everybody. Welcome back to RMUS Tech Week. And for joining us today, this is our session on advanced inspection platforms and sensors. We've got some really exciting stuff to talk about today. Really sort of unique, purpose-built vehicles and really interesting sensors. So we're joined today by Jack from HausBots, Nikita from Skygauge, by Jacob from OFiL Sensors, and by Tim from Nordic Unmanned. So, guys, if you could introduce yourselves, just tell us a little bit about yourself, the company that you work in, what you guys are doing, and sort of how you got to this point. Let's start with you, Jack.
Sure thing. Thanks, Fraser, and to the RMUS guys for inviting HausBots along. My name's Jack. I'm the co-founder of HausBots, and HausBots are building crawler robots for industrial and infrastructure inspections. We're based out of Birmingham. Birmingham in England. Started the business around 3 years ago now, and we've got our robotic systems working in most of the major countries around the world. Our first and main product is the climbing robot HB1, and the special thing about our system is its ability to climb on any surface. So where other crawler robots on the market may focus on, crawling in pipes, or maybe they're based on magnets to climb on ferrous surfaces, then we've developed a new system that allows our robot to stick to surfaces like concrete, like stainless steel, and other non-ferrous surfaces. We then partner with NDT equipment manufacturers to undertake physical NDT tasks where you need to take readings from the surface or measurements with a probe attached to the robot. So we do things like ground penetrating radar on bridges and concrete storage silos. We do things like phased array ultrasonics on stainless steel storage tanks, and the robot can be integrated with a variety of different payloads depending on the customer's needs.
Very cool, very cool. And so I have a question that I think we all want to know the answer to. How did you come up with the name HausBots, and is there any significance to that?
I'm going to give a bit of a rubbish answer, but we wanted a name that sounded a bit German because the Germans know what they're doing, and house sounded like a pretty nice word to use. So it's nothing other than we wanted to pretend like we were good at engineering.
Fair enough. Fair enough. Um, can you share with us some details about the company or the system? Do you have any video or something to share with us?
Yeah, sure. So I'll get my screen set up now. So the system that we've developed is it works on a principle called ground effect. For the Formula One or any other racing series fans out there, you'll have heard of ground effect as the way that a race car sticks to the surface. In our case, then we have two fans on the robot that are moving a high volume of air, and it ends up creating a kind of lifting force, a little bit like an aeroplane wing. And that lifting force is pushing the robot into the surface. Crucially, it's not creating a vacuum or a suction area, which may be the obvious solution to making a climbing robot like this. And our robot's got maybe 1.5 inch gap between the surface and itself. So without a seal is how the robot can climb on such a wide range of surfaces and create a large payload. We provide it to customers as just kind of an out-the-box platform, and then we provide support to integrate various NDT sensors. So when you turn up to a site, you have the robot, the climbing robot in one box, and you have the control station in another box. And we add a variety of different payloads like improved camera systems. where we can and we regularly inspect things like bridges and bearings on the undersides of bridges using this camera. So the robot's kind of climbing up the pier of a bridge and taking just basic visual data. We can also integrate to a variety of these kind of NDT payloads that I mentioned as well. So ground penetrating radar, ultrasonic thickness, and others. And yeah, we have kind of three key use cases for this technology. One is silos and bulk storage. So you might find this in kind of the cement industry, the mining industry, transport infrastructure. So we do a lot of bridge work, and then chemicals and oil and gas, where the robot's being used to undertake inspections on storage tanks. And really, the kind of key thing that a crawler enables you to do over other types of technology is whole asset mapping. So in this example where we're inspecting this cement storage silo, these are two different data sets we took with different concrete NDT payloads. And this is a map of the entire surface of the silo, which just wouldn't be economically viable with kind of any other method, and is certainly much more accurate. So here in these data sets, we're looking at things like the corrosion potential of the rebar, and in this example, we're seeing the depth and the thickness of the concrete mapped over the whole area. So yeah, that gives you a brief idea.
Very cool. Very cool. Okay, moving to an entirely different medium. Tim, could you tell us about yourself and your company, please?
Sure. I'm the CEO of Nordic Unmanned North America. So we're the newest entity here in the U.S. and North America, representing Nordic Unmanned Global. That was founded in 2014 in Sandnes, Norway, the southwest corner. And the foundation of Nordic Unmanned is both OEM products and services. But our biggest vertical is services flying large Group 2 and above platforms. We operate 7 Textron Aerosonde and Schiebel Camcopter platforms for the European Union EMSA in various roles for the European Maritime Safety and Security Agencies, doing immigration monitoring, search and rescue, and as well as doing emissions monitoring, where we sniff the stacks directly of commercial container vessels to European regulatory standards. What gave us the foundation, we were the first company in the world to get a light unmanned operator certificate from EASA. So that opened up the pathway for us to be able to fly BVLOS. And what's significant is we can actually fly BVLOS with additional systems within the confines of our certificate without having to gain a waiver, an exemption, or an addition to our certificate. And a great example of that is one of our subsidiaries, Drone Matrix, which is a drone in a box company in Belgium. We operate multiple boxes at the Port of Antwerp, doing inspection, safety, security, remotely operated in our operational control center in Norway, thousands of miles away, with just a technician on site to monitor and maintain the systems that are doing that. And we were able to do that with just updating the EASA regulator and the Belgian CAA with our SORA risk analysis to do that. So that's the foundation of who we are. We have some OEM products. We just talked about the drone in a box with Drone Matrix, fantastic solution for those security, safety, and inspection needs. We have a tactical rugged quadcopter that's been in use with the German Army for over 10 years. And we just have another framework contract for another 10 years with the Air Robot, which is another one of our subsidiaries in Germany. And we also have a couple other products, a rail rover drone that does rail infrastructure inspection, as well as some other sensors, radiation, Radiac sensor, as well as a drop payload. But really the foundation of Nordic Unmanned is that we operate as an aviation company first. Most of our pilots are not Min-Time Part 107 or Transport Canada or EASA remote pilots. Most of them are certified flight instructors of manned aviation, commercial and ATP and ATPL pilots. We operate under that Luke certificate just as you would with a Delta Airlines equivalent. We get audited by EASA on a weekly, monthly, and sometimes daily basis to make sure we're maintaining compliance with our safety management system and with all of our operational op specs that are out there. So that kind of gives you a little bit of us in a nutshell. My background, retired Air Force Colonel, C-17 pilot, and KC-135 pilot, have over 15,000 hours in about 12 different type-rated aircraft. Been in air carrier, part 121, 135 aviation, so charter, as well as air carrier. And I worked at FAA headquarters and led the teams that wrote Part 107 and the drone registration rule. So was part of those teams that stood up the AUS division that everyone knows and loves. And I say that with a smile on my face as we have to go after waivers and exemptions for BV laws here in the U.S. And then from there, I moved into rail and transit, doing safety, compliance, innovation, bringing drone programs to the state of Maryland, Amtrak, as well as the Metro in DC. And then found my way over to Easy Aerials, the COO for a drone in a box company in Brooklyn, New York, and here at Easy, and now here at Nordic Unmanned. So thanks for putting this together here, RMUS, and look forward to taking questions and just innovating with the industry here today.
Great. So thanks, Tim. That's really interesting, and these are some really sort of unique capabilities. So you guys operate as a service provider, of course, but let's say we want access to these capabilities, but we want more involvement ourselves because it's a very remote location and the staffing is challenging, or if we have if we're sort of very specialized SMEs, are there other models? Do you work with partners? Are there other ways to use the type of systems and capabilities that you guys are offering?
Yeah, absolutely. So, I mean, we all know in the industry there are a few different models, right? There's drone as a service, which has become a predominant model. And in the end, most of our customers and clients, they don't want to buy a drone, right? They're looking for the data. They're looking for the data, the service, the operations, and the maintenance. The drone itself is the Roomba vacuum cleaner, right? So we go to work in the morning, the Roomba's in the charger, and we come back, the floor is clean, and the Roomba's back in the charger. You know, to a customer or client, whether it's the U.S. military in a COCO ISR doing intelligence, surveillance, reconnaissance, or whether it's European Union EMSA doing search and rescue operations, we're doing it more efficiently, more effectively, and at a higher level of safety, taking the human out of the loop with regards to our safety management systems. So we have various partners around the world. We've got joint ventures on most continents to make sure that they maintain the standards that we do, because we just can't put our operational certificate at risk with regards to not just company reputation, but having that LUC certificate taken away would take away our bottom line. So it's very, very important for us to maintain those high level of standards that are out there.
Fair enough. Sounds good. Um, Jacob, can you tell us about your company, the sort of the unique sensors that you make, and how you guys got here?
Hey, yeah, thanks, and thanks, Fraser, and thanks everybody here for joining and being part of this panel. Very quickly, I think is what we try and do at our OFiL. We're part of OFiL Systems. We're a global company. The Canada representative here for Canada manager. What we're really focusing on here is making sure you have in-depth inspections about your utility lines, your gas inspections, or oil preventions, among others. And what we really do is we develop and manufacture a UV bispectral optical system, which is our proprietary solar blind technology, which at the end of the day, we're using our technology to be able to detect leakages of electricity or coming out from wherever it be your utility lines, your high distribution, medium distribution, your motors, oil spills as well from the water, and other stuff that are happening in real time from wherever you are. And we have what's important about our technology is it works in daytime, but the last the last sort of piece behind it that's really really key is you can actually go out there, take our systems, our cameras, pinpoint it at something, and actually tell you within a few seconds that there's something actually happening, something wrong, or something leakage, which could actually lead to what we call the corona effect. Corona being a partial discharge that's coming off your electrical lines or coming off other systems that you may have in place. And why is all this important? Because you go out there, you do other technologies who are out there, and they give you a general overview of what could be something wrong. They give you a large heat spot. Unfortunately, that heat spot is not concise to pinpoint what the issue is. And what's great about it is, sorry, what's really great about it is we can use the cameras that we have um, to really identify what the issue is very, very quickly. You can take videos and photos as you're doing the inspection, and you can do the inspections for multiple assets. That's the introduction of what we do.
Great. And so just for some context, what types of defects are we looking for with those sensors,
And
and what would be the
what I
consequence of
can
those
show you
defects?
here is let me share the. Do you want to show the quick video that we have here? And I'll do a quick explanation of what it is. Yeah. So you can see what we have here is this little video that we a little image. What it's actually doing is showing you a high voltage utility line here in Canada, and we're actually having what we call popcorn pop up show on the screen, which is the red dots. But most importantly, it's showing you there's a discharge coming off of those lines. Why is this important? Because there's so much electricity flowing through here, and if you're not actually detecting there's electricity leakage or electricity coming out from there, you're not actually understanding what the issue is. And what these little points are actually showing you is, from a broader perspective, they show you that there's something happening there. At the bottom of the screen, you see the gain, which is where you use to measure the amount of discharge that could be happening on there. And then the most importantly is to see the 61,000 reading, which is a humongous reading of amount of discharge that's actually coming off those lines. So to put it this way, it's like a pipeline. You have a pipeline of electricity flowing, and there's obviously a certain amount of voltage of electricity that's flowing through there. You actually want to make sure that what comes in comes out 100% at the other end. And obviously what's showing on here is that there's 6,100 photons per minute are actually leaking from this particular indication. If you go into some other images that we have on here, it'll show you, so that particular issue, you can see a little scratch here at the bottom of the screen. You can see sort of in the middle, so in the middle of the screen, you see like a black line right in the dead center of it. And what that black line right in the center of it is actually showing you is the actual scratch that happened on there. And this is at a major substation here in Canada, 700 plus kV that have recently been installed. And obviously there's a large leakage. You saw there 6,000 plus electricity that was happening there. And our system was actually able to detect it. So we zoomed in, identify what the issue is, and then we helped in this case, the Canadian utility, identify what the issue is, create a simple report that we have reporting software, and we have more advanced AI software coming up as well. And in this case, they know exactly what the issue is. They know what needs to be repaired. And it just takes them just a few minutes to inspect it, and boom, they know exactly what it is. So here's another example. It's a short video. So if you want to go back for a second. So if you could just go back for a second, yeah, that little video there. It's a short little video. It's just showing this other corona, also partial discharge coming off different areas. And what's great about it is our cameras go from 60 to 100 meters away, or 50 to 100 meters away, or from short distances, even being just very close by as well. So you don't have to actually climb the walls or do it from different angles. But most importantly is our technology works from wherever you are, and you can have it be you can have it really work on it from wherever you are in terms of on the ground, whether it's aerial, whether it's fixed, or whether it's from helicopter as well. So what it does is basically we have a solution for all different kind of environments, and the price ranges all. But the most importantly is very short inspection, very quick identification of what the issue is, and very large return on investment, because you see the amount of electricity leakage that's happening, and at the end of the day, you know exactly what the issue is, and you're able to fix it right away. So that's what we do.
Fascinating. Okay, and last but of course not least, Nikita, please tell us about yourself and your company. I've always been really impressed by the aerial platforms you guys produce. I think mechanically they're really
Sorry, I'm having trouble
technically
hearing people.
complicated and very unique. Please go ahead and tell us about your company.
Awesome. Thank you very much. Yeah. Thanks for having me being a part of this panel here. Is one sec here. Is the screen share coming through okay?
It is.
All right, perfect. So yeah, bit about us. So I'm Nikita. I am one of the co-founders here at Skygauge Robotics, in charge of everything on the commercial aspect of really our company. And what we've really done is we've created a drone for doing ultrasonic testing. So this is for measuring the metal wall thickness. And we went into this line of business because these inspections have to be actually fairly frequently done on a wide range of industrial structures, anything from these large installation columns, tanks, piping, and in other industries as well, such as shipping, infrastructure like bridges, and much more. And the current methods really require workers to go up on ropes and scaffolding. They go and collect this data, and as you can imagine, these are very large structures. So we have to use workers on ropes, on boom lifts, on scaffolding to go and collect all this data. This method can take like weeks to complete, hundreds of thousands of dollars, and we're introducing risk to people because we're exposing them to work at height. So our vision is to create a drone that can actually do this, performing the job in days, not weeks, turning a 2 week job into actually a 2 day job, performing that job orders of magnitude much more cost effectively. We've seen anywhere between 50 to 90% cost savings against the current man methods. And there's no risk of workers falling because you're not having them at height. Now, Nikita, you're probably saying that drones today have been doing a ton of inspections. How is your system different? Most drones today have really been focusing on doing visual inspection. Think of like taking photos, thermography, mapping, but they haven't been able to actually physically approach and make physical contact with the structure, which is really what you need for this domain of ultrasonic testing. So think of the same way that doctors really use ultrasound to check the health of people. Well, inspectors use this industrial ultrasound to check the health of structures. And this is the reason that we're really uniquely suited for doing this type of work. So we have really reinvented how the drone flies. So our drone, the Skygauge, flies by tilting the rotors to move while the center body remains stable. This way, we're able to fly and approach the structure and take these readings in very specific locations of the structure. These are some of the use cases that we've seen our users really have the system for. Anything from chimney stacks to towers, columns, tanks, stacks, any large infrastructure that's really hard to get at. And on top of that, we've found that we need to develop some additional features on top of this to better improve the user experience. So as you can see here, there's actually a grid that displays for the operator. So if you imagine flying a drone in front of a tank, on the FPV, you will just see a blank wall. So in order to help the pilot gauge distance from the surface, we actually created this 3D grid that kind of pops out of the surface to help the pilot gauge distance. Additionally, this system also helps the pilot understand distance between the inspection locations. So if you wanted to, say, take a reading every meter going up the side of the tank, this system helps you understand how much distance you're traveling between the inspection points. And this is about the actual thickness data that we're collecting. So we actually have a force sensitive probe at the end of our system there. So as you can see, it entered with not flush contact, and then it moves into getting perfectly flush contact with the surface and getting an accurate reading. That's because we have a force sensitive probe at the end of there, and the drone is actually able to conform to the surface, get perfectly flush, and get accurate wall thickness readings like this. And then that is actually used in our reporting suite. So this is a conventional inspection report, as you see here, would really display a grid of numeric thickness readings, which you would have to rely that the operator took those readings in the locations that they said they took them, but additionally correctly interpreted the data live on site and at height. And what a system like this really does is it allows you to have a level of transparency that was previously not possible. You can see the exact data acquisition of the ultrasonic thickness reading, visual data, and anything else that you would want to see out of inspection reading. So yeah, this level of transparency really has been possible by introducing drones into this line of work. So yeah, that's everything about our product for now. Happy to answer any questions that you guys have.
That's awesome. Thanks, Nikita. Definitely one of the more interesting aircraft platforms that I've seen in a long time. Okay, Jack. So your climber crawler robot, super interesting. Please tell us about how this came about. Was this the result of a specific need or a development in technology? What sort of prompted the development of this platform, and what has been your most frequent or successful use case so far?
Sure. So we started in a very similar way to how Nikita's describing. All types of work at height is a big problem for operators of infrastructure. In the markets that we play in, pretty much all major infrastructure has mandated inspection codes. So in the road networks, then you're inspecting the road, the bridges up close, probably once every 5 years. Obviously, in oil and gas and in chemicals, you've got the above ground storage tank inspection codes in both the American Petroleum Institute and then in Europe as well. So infrastructure operators are having to do this work, and the only option they currently have is scaffolding, rope access, all these expensive and dangerous methods. So we began our project knowing that information. My background is in the industrial space, and I was aware of this problem happening. It just so happened that my co-founder at the time was solving this problem for a slightly different use case at university. So our technology was kind of developed out of a university in the first instance. And initially, the idea was to apply this new climbing technology to more maintenance-focused tasks. So things like painting and repairs was the initial plan for the technology. But as we started sharing the platform in the wild, then most of the pull was coming from customers with inspection use cases. And yeah, now our three key areas are concrete constructed storage silos, and they're typically found in the cement industry, the mining industry, grain storage, and other bulk storage kind of industries. We have these big concrete silos, typically found around sort of like port infrastructure or other types of storage facilities, and then obviously in manufacturing facilities as well. We have the transport sector, and most of our work there is on bridges in the road sector. So we're doing various forms of non-destructive and visual testing in line with the various codes that the government and the agencies outline, and then chemicals and oil and gas, and we're about evenly split across those three areas. And really, what we're trying to build is an enabling platform for our customers to use that enabling platform for a variety of tasks. So, whilst those three are the main focus areas that we do now, and we have most of our kind of case studies built up in that area, like I showed the videos from, That doesn't mean to say that the robot can't be adapted for people's specific use cases.
Great. So, are there any limitations on what type of sensors we can put on the robot? I assume there's a weight limit, but
Yeah.
what else should we know about that?
Yeah. So the basic version of the robot has a 6 kilogram payload. You can then obviously exert force into the surface as well with that payload. But usually that's the kind of limiting factor is if customers maybe have heavier payloads that may need to be integrated. There's a few ways that we've dealt with that before, but then you start edging into kind of custom solutions. So usually the number that we say is 6 kilograms.
Okay. Very cool. Okay, Jacob, your sensors are sounding incredibly important, and I imagine we could employ them in many ways. Why the decision to integrate with drones? What's the significance of using these sensors on aerial platforms?
Hey, Fraser, that's a great question. Drones are, as you know, the evolving way of inspecting or doing many tasks nowadays, as my colleagues here have alluded to. Um, but what's great about it is, we don't, we partner up with companies like yourself and your partners here to attach our drone to them, so get a bigger aerial picture for things you can't always see or pinpoint from the ground. And I think, from a aerial perspective, sometimes you're also able to see not only a bigger aspect, a macro picture per se, for like a substation, for utility lines that are going across multiple kilometers, and they're efficient and they're quick to use. And at the end of the day, you know, depending on the issues and depending on what the troubles could possibly be out there, or the regular inspections that the companies are doing, whether it's a service companies or utilities or other oil and gas companies for their assets. At the end of the day, you want to get sort of the bigger the assets, the longer the bigger radius that it encompasses, the more nested is within a forest per se or other locations, is the drones really allow you to get into those locations without having to get yourself deep into the bush per se, or walk around an entire substation and manually be inspecting everything with a manual camera. Those circumstances also make sense if there's something you can't see from the air, but the air gives you, as you can probably identify, is a bigger macro picture because of what's happening. And then from the air, you can actually use the same thing, zoom in and pinpoint the exact issue that I showed you beforehand in the videos and pictures at the end of the day. So again, looking at a macro picture, they can actually zoom in from the air and get a much bigger and much quicker identification of what the issues are without having to be, on the ground and be inspecting everything manually from a ground perspective. That's sort of a huge benefit in terms of time and money, obviously, and ROI that we get behind all this.
Makes sense. Are there any other benefits? Drones would typically enable real-time geotagging of data, stuff like that. Any other specific benefits to using drones, or is it mainly just about the access?
Oh, there's many benefits. Well, obviously the benefits for using the cameras, which are cheaper to use on drones than they are to use on handheld, depending on the situations, on how big the assets are. Obviously, the bigger the longer the bigger inspection that you want to do is the wider, longer, the more kilometers per se that you can inspect in a much shorter time period. And that's sort of the bigger thing is, we're still using the UV inspection, we're still able to pinpoint exact issues, but we're able to inspect them in a much quicker aspect of it. And to us, the using drones, we don't sell the drones, we have our cameras attached to many drones, and we can accommodate to wherever's out there at the end of the day. But being able to attach and accommodate to those, you're getting a whole different perspective of what's out there. And when you're doing an inspection, at the end of the day, the utility or the end customer wants to make sure they get a full macro view of everything that's on there, not just from the ground or not just from the air. They want to get a combination of both. And that's where the drones really have a much bigger aspect that you're not able to see sometimes on the ground. And ultimately, these are the ones that really give you the more honed down picture of what's happening from an air perspective that you can't always get without having to climb on a ladder or go on a big helicopter and do that.
Of course. Okay, thank you. So Tim, given the nature of the systems you guys are flying and the types of use cases you're going after, these are of course a lot of BV loss applications and lots of considerations there. A lot of interest in these capabilities right now as regulations kind of develop. So could you tell us about some of the more interesting use cases you guys are running and some of the sort of successes and challenges involved there?
Yeah, so one of the most interesting, we mentioned it earlier, was the missions monitoring. So even though that all the countries of the world partake in maritime admiralty law under Annex 6 for emissions monitoring, each country has its own regulatory compliance standards based upon law. And the European Union is at the forefront of that, of actually mandating regulations. So if you kind of equate it to a speeding ticket, where each of us are from, your police officer pulls you over and you pay a speeding ticket, or in most instances it's automated. Well, with regards to the European Union, prior to us flying BVLOS with an emissions monitoring sniffer pod payload that we have that measures NOx, SOx, CO2 levels, and methane discharges, there would be a random audit by a Coast Guard vessel, which is in limited supply, to be able to do audits of certain container vessels. So, in a lot of instances, shipping companies were getting away with going above the mandated requirements. Now we've been doing this into our third plus year, and we now not only have the operations, but we have the data. So, for instance, when ship X comes into, say, for instance, the port within France, we already probably have at least 2 or 3 sniffs of that vessel and can tell you that it's most likely going to be compliant or non-compliant based upon our previous sniffs using BVLOS drones to do that. And so really we go back to that analogy of clients really aren't buying drones, they're buying data, they're buying service, right? So in that regard, the European Union EMSA we've increased their capability to do surveillance hundreds of percent, and allowing their Coast Guard vessels to focus on things such as search and rescue and other missions that are higher priority. And when the drone's up there, it's not just doing emissions monitoring. It's also has a payload to do, for instance, we're using a TASE 400 to do search and rescue and immigration monitoring for safety and security. So those are very important missions. They're expanding. We're actually expanding our fleet to use the HyperQuad VTOL version of the Aerosonde that we'll be putting into use here at the end of 2023, beginning of 2024. We'll actually be the first operator of it before the U.S. military has even put it into full operational use. So that's a really interesting one. We're just getting our feet wet, no pun intended, here in the U.S. with the EPA and the U.S. Coast Guard to do the same things with regards to the emissions monitoring. So looking forward to kicking off a program here. So I think that's one use case that's very unique. The Port of Antwerp using our drone in a box system. That's another one, as drone as a service, as we talked about the different models that are out there of doing a full operational model or using a partner or other type of construct. That actual system, not only being remotely sighted, that system is used by multiple clients for that same system. So for instance, the Port of Antwerp, the operational portion wants us to do inspections of the cranes. And I think we mentioned from some of the other partners that are here today that a lot of this, the dull, dirty, dangerous, also requires, loss of on-time performance, taking more human capital to do the required compliance inspections, et cetera. Case in the U.S. and beyond, the way that an inspection happens on one of the cranes that take containers off of a container vessel is usually the human gets out of the crane, and then you have to stop operations of moving containers off a vessel, and then you have to harness up and get up there and do that manual inspection. And it's limited. It's limited to where the human can do it versus a drone being able to do that real time, not stopping operations. And we're doing that today at the Port of Antwerp. And then when we're finished that, we go and do a security sweep. Lots of security issues around different negative groups of stealing, theft, corruption within large ports around the world. And then thirdly, it's also logistics tracking. So the same drone will use vision to go look at OCR or barcodes to be able to read to know where your products are. And so we're getting revenue streams from 3 different clients to max utilize that platform. It goes back to the model of any aircraft. You want to max utilize that asset as much as you can to be able to increase revenue. If Delta Airlines had a 737 that's sitting on the ramp, well, that's not generating revenue. That's why you see an aircraft turning 5 to 7 times a day to max out its utilization rate so that you can balance maintenance with operations. So those are some unique use cases that we have that are out there.
Those really are some very, very neat ones. Yeah. Thank you, Tim. So, Nikita, similar question as we asked to Jack. What sort of drove the need for this platform? Was it a demand from industry? Was it some sort of technological development that enabled your idea? And what challenges did you have to overcome to get to the point where you are now?
Yeah, for sure. Good question. So originally, we started this company not the way that you were really supposed to. So we had this drone design, as you saw there, and we started it with the idea that we worked fantastic together as co-founders and still do to this day. And that we had a really unique technology that we had a patent on, and that we were in the high growth market of commercial drones. So we felt that at that time when we co-founded it back in 2016, that we had enough of the foundational building blocks potentially for a great company. And it was really my job to find out what problems it solved in the market. So after doing a lot of research in the space, I found that this design was actually really uniquely suited towards doing physical work. So that involves any type of work that involves physically contacting a surface, anything from NDT, like our first use case, to painting, cleaning, sanding, and any type of general work, really. So after searching this market and understanding it a bit more in detail, I found ultrasonic testing was a fantastic way to enter the market for a couple of reasons. It is a pretty basic form of physical work, so just precisely placing a sensor onto a specific area of the surface that really we found that drones today could not address because of their lack of stability. And we found that there was a lot of money being spent to solve this problem, and that really we were on the cusp of a real high growth market subsegment where drones were being extensively used and adopted in these industrial refineries for doing visual work. And we found that we could hop onto that trend and kind of utilize the work that they've done in terms of being able to operate drones at these industrial sites. And yeah, those are the main 3 factors why we entered the non-destructive testing space. And yeah, since then we've launched our product in Q4, and it's seen a fantastic response. One of our largest clients has been Transport Canada, actually. We're working with them to do inspections of bridges, storage tanks, ships, and all of Canada's diverse infrastructure.
Very cool. And I mean, personally, I love the concept. I think it's really cool how you guys made that work. But I gotta feel like there were some serious challenges along the way in developing a product like that can do this difficult job successfully. What are some of the major ones that you guys overcame?
It's really just an iterative testing cycle that is just very different for a system that flies, because like say you create say hardware software stack on a drone and deploy it for doing flying, you need to create a lot of different testing fixtures such that it minimizes potential damage to the drone if there is a bug that's found. So doing a lot of that testing has been where a lot of those challenges have really come. Uh, Through a lot of trial and error, we were able to get through it. But yeah, it was a journey to say the least. But yeah, we've come through to the other side, and yeah, now we have finally units deployed with customers.
Amazing, amazing. Thanks. So guys, this is sort of a question for everybody here. How can we? How do you foresee your sensors or platforms interfacing with AI in the future to speed up decision making?
I guess I'll start on that one. So it's not something that we as a company get involved with, because there's all sorts of other players out there that probably have the better skill set. But I think an obvious one is trawling through vast amounts of data to firstly highlight the key areas of concern. We did a visual survey of a silo recently, and the customer wanted kind of every inch of the silo covered, and that was pretty much thousands of pictures and gigabytes and gigabytes worth of video. And at the time, we handed it to the customer to then manually look through. But I know that there's already products on the market that could quite easily look through and identify cracking or key areas. So I think that's one area. And then the next thing that again a number of players are already working on is using that information for better predictive maintenance. So I'm sure that in the not too distant future it will be standard to upload all the different types of data sets that all the different companies that have been on this phone call have been can offer into one central platform to kind of help the infrastructure owner predict maintenance requirements in the future. It's not something that we're working on, but I'm sure that there are, or I know that there are other companies out there. So that would be my take.
I like that. Sharing is caring, right? So in a perfect world, we would have all that data accessible. So at this point, I want to just ask the audience to post any questions they may have in the chat. We'll come back to them very shortly. If anything we've discussed is making you think or you have questions, please post them now. We'll get to them before the end of the session. But just to follow up that last question, guys, what about automating the actual data collection process, the flight plan or the travel plan with the vehicle itself? Is that something you see as being important? And are you working on implementations like that?
So I'm just going to speak a little bit quickly on from OFiL perspective. What we're doing right now is, as I mentioned, what we do is more inspections well, we help companies do inspections. We don't do the inspections ourselves. But what we're working on is some AI technology right now that will actually be able to identify what the issues are happening or issues that could be coming about to ultimately give you an idea of what needs to be fixed rather sooner than later, or what will become an issue very quickly if it doesn't get fixed. And it'll give you sort of like a green, yellow, or red flag per se, or like a street light. These are just some ideas that we're working on, and that's how AI is really going to be helping us out. So you're not going to do your general inspections. You're going to identify the key hotspot issues right now, identify how much money you're losing per hour, or per minute in terms of electricity leakage. But our AI is what we're actually developing is a specific reporting software that really allows us to allow the clients, per se, utilities or service companies or the drone inspection operators, to really go in there and say, hey, not only do we find some issues right now, but we actually know some other issues are with AI that we've identified, some of the software that OFiL has developed to really identify that we've identified that there's actually issues coming up, and being able to do those more with our for drone, because you're covering a much broader area much quicker, a large more cameras and pictures. That's something that's going to have a big change and a big impact in terms of what's out there, and that's one of the impacts that we're going to be having in the AI with robotics.
Fantastic. Anybody else have a comment on automating the actual data collection process? I have a feeling you, either Jack or you, Nikita, will have some plans in the works for this.
Yeah, I can talk a bit on our end of that. So there are a lot of companies that are in the like drone autonomy space. For now, we're more just specializing in creating a drone that can do physical work. Um, very There's like no drones on the market that can really do that today. We do see potentially layering on some autonomy features onto our drone. Really, right now they've been kind of more pilot assist features, but it's really driven by the areas that customers really find most critical, because ultimately they guide really how and where our R&D efforts really get put into. So it's one area that we are looking into of many to really add value to our customers.
Yeah, and
Cool.
a similar answer from us as well. I think first and foremost, then we've kind of identified that the value proposition is just being able to do that type of work in the first place, and so our focus right now is trying to make the best platform to be able to do these types of jobs. The customers already getting tons of value from you know no scaffolding costs, no work at height costs, lower downtime of the asset, all of these extra benefits that then that final value proposition of autonomy it isn't quite as strong as basically make a really good product first. So that's our take on it. But I'm sure if you spoke to us all in 5 to 10 years, then everything will hopefully be automated. But maybe that's the optimist in me.
Well, we'll be sure to do that. And anyway, yeah, I did certainly have fun operating your system manually. Anyway, so I guess I won't hold my breath for that. Okay, guys, we've got about 3 minutes left. Anyone in the audience, if you have more questions, please go ahead and post them now. We do have one here from Alex. This is a question for Jacob. Any other use cases for the OFiL system? Any other applications, I guess, outside of utilities transmission, where we can make use of your sensors?
Yeah, for sure. So if you can see very quickly my screen here, these are just a quick idea of what we can do with our products and our solutions. As you know, obviously in inspections of utilities, as I mentioned, predictive maintenance for trains as well, which is really important. Like LRT, like high-speed trains, which is really a big industry for us as well. Petrochemical industries, able to identify oil spills and other chemicals that are leaking on water. That's a big one that we have. Also using drones for that. That's a really important one. Manufacturers of electrical grids being able to understand their motors, the rotator motors, as you call it, the inside of the motors. It's become a really big area for us. High voltage labs are those ones. There's Kinetrics in Toronto that uses our labs as well for, and also for researching and testing apparatuses before they go live. UV signal detection for homeland security. That's another one that we're in. And then just going back to oil spills for environmental organizations. That's a big aspect that we're growing in right now, and there's a lot of demand for that. But obviously, if there's something particular that somebody needs or somebody wants, we'll be happy to talk to them and see if we can provide them a solution for that.
Perfect. Okay, guys, we do have to wrap it up here. We have another session starting in about 6 minutes. So just want to thank you all for joining us. Really good to have you all here. Really interesting conversation. Thanks so much for joining us.
Thank you very much.
Thanks, everybody. Appreciate it.
Thank you.